Good morning. So today's lesson wraps up everything that we've done so far on the data representation of images and sound. So this is an open book assessment. I don't want you searching and copying and pasting definitions, but you're welcome to use your notes from this topic. I want you to use this to revise and prepare rather than to sit and feel miserable if you don't know the answers to anything. So what's covered in this end of topic? We want to know about bitmap images. Interestingly, the specification means that we don't need to know anything about vectors. We're only interested in images that are split up into a grid of pixels, a two-dimensional list or a two-dimensional array. We want to know how all of the colors are represented in binary and how things like the image size and the image resolution is going to affect the size and the quality of an image. We want to know about the limitations, as in if you've only got a certain number of bits per pixel, what's that going to limit in terms of the quality? And remember, you don't have to actually perform any calculations to find out the answers, but you do have to construct an expression. That means that you multiply the width by the height by the number of bits per pixel to work out the file size. And then often you have to divide by 8 to get to bytes. And then in this case, you'd have to divide by 1024 because remember, Edexcel uses these weird IEC units, which are always factors of 1024 for the size. We want to also do the same for sound so that we understand about analog being a smooth signal, but it's something that a computer can't capture. You have to split it up into a digital signal using zeros and ones. We want to have a similar expression that we had for images. We want to do the same for sound. So you have the length of the sound recording, you have the frequency of sound recordings per second, you have the number of bits per sample. Multiply all of those together and you get the total number of bits. And then again, you have to divide by 8 to get to bytes and divide by 1024 to get to kibibytes and 1024 again to get to megabytes and all of that. We want to talk about the limitations, which means what is it that will limit the quality or what is it that will increase the file size, which leads to a discussion about data compression, lossy compression, lossless compression. All of that is covered by this topic on P18. So work your way through. If you need any help, then we'll pause the video and we'll go through the questions and I'll record those too so that everyone has the same level of help as we work our way through. I want to know how much you know rather than me and rather than the person sat next to you. So there's no point cheating here, but do your best and let me know if there's something that you don't know about that we can explain together. Okay, so we're going to go through question 2 together. It says an image has a file size of 689 kibibytes, its height is 700 and its width is 900. Construct an expression to calculate the color depth of the image. Now, I've told you to remember the size of the image, so we'll start with that and then we'll rearrange it. So if we say the size is equal to the width multiplied by the height, that's the total number of pixels, multiplied by the color depth, so I'm going to say bits per pixel, then we should be able to rearrange it. So construct an expression to calculate the color depth of the image. The color depth is the bit per pixel. So if we want to have that on its own, we need to divide both sides by the width and the height. So let's see, color depth is going to be the size divided by width times height. So what is the size? It is 689 kibibytes, so multiplied by 1024, multiplied by 8 to get to bits rather than bytes, divided by 700, that's the width, and also divided by 900, that's the height. So as long as you remember the total size is the width times the height and the bit per pixel, and that you can practice your GCSE maths of rearranging equations, you'll be fine, and I'm sure your spelling is better than mine. Okay, so let's have some more practice. An image file has a color depth of 2 bits per pixel. That means that you can have 00, 01, 10, or 11. 2 bits means 2 to the power n, where n is 2. 2 squared is 4. We've just seen those 4 different possible combinations here, 0, 0 up to 1, 1. So describe the maximum number of colours that the image can store. It's a describe question with 2 marks, so it's not enough just to say 4 colours. You could say that you've got 2 bits with 4 possible combinations, and then you can list them. Would be the safest way to get the 2 marks here. So it looks like most people have pretty much finished P18. Do remember, please, to submit it onto, can't find the right place, onto the VLE on half term 9. It goes on half term 9-3 data. And then just a reminder that at the end of each lesson, if you've got some time left, do click on the submission thing and you'll see your feedback so that you can make any changes and resubmit. If you manage to get everything all to excellent, well done, some of you have, or even if you think, well, I haven't got time to get them all to excellent today, I would recommend that you work through some of the revision quizzes. So you've got your paper 2 coming up in March, so it might be that the revision quizzes for the CT section might be the best use of your time. Also want to flag up on class charts, I sent a link to the video walkthrough of the revision workbook. At the back of your revision workbook, about page 105, you've got a practice paper 2 question paper. So you can find all of the resources there and the videos that guide you through how to approach it with top tips. So remember, in your paper 2 exam, you might not necessarily be in this room, A13. You won't have posters on the wall. You don't know who you're going to be sat next to. So we want to make sure that you're familiar with opening up Thonny, finding a file, save as, that you just know how to do that on a different. I'll confirm where you're going to be as soon as I know, but I just want you to have practice. So I would strongly recommend you download these files at home, you install Thonny at home, or you practice at the end of the lesson to make sure that you know what to expect from that paper 2 so that there's no surprises. All right.